Got to give the people, what they want. Ghostface Bass is in the house. Catch the blast of a hype verse. Y'all don't know about that. That's Wu-Tang. Anyway. Alright. I need you to write this down. Writing with fractional exponents. The flowers are growing exponentially. On January 1st, there are 50 flowers. After 6 weeks, there are 150. Write the equation to model this. First off, this is the only one I'm doing. It's been a long couple of days trying to still make this happen, but hopefully this will help support what we've been doing and get you all ready for Monday. We're just going to have one, so hopefully this doesn't take too long. All right, so let's try to make this happen. So we're going to solve this the way, you guys actually already know how to solve this. We're just going to look at it with fractional exponents, right? So we start by making a chart. So we know we have, now saying on January 1st there are 50, after 6 weeks, we're talking about weeks. So, talking about weeks. At week 0, on January 1st there are 50. Week 1, 2, 3, 4, 5. And at week 6, there are 150. You already know how to solve this problem, right? You know, oh, okay, I gotta figure out, 50 times B, times B, times B, times B, times B, times B, equals 150, right? All those have to be multiplied by B. Or in other words, this whole thing is what? B to the first, second, third, fourth, fifth, sixth power, right? Let me make sure that I'm on track, right? So this is all B to the 6th power. So 50 times B to the 6th power equals, where the heck did he get 200? Ah, he messed up. Equals 150, right? Right? So I divide this bad boy by 3. Wrong. I divide this bad boy by 50. I divide this bad boy by 50. I end up with B to the 6th power equals, there's my 3. So here's the key, right? Really this triple. 50 times 3 is 150. This whole thing is really moving like times a 3, but it's not in one spot. It's over these 6 spots. All right? So to solve this for B, right? I take the 6th root of that, and I take the 6th root of that, and I end up that B equals the square root of 6, the square of the 6th root of 3. So I end up there, right? I just solved this. So jumping right back in here, I know, I could say, okay, well, B is 6th root of 3 to the x. This isn't the proper formation, though. This is not how you're ever going to see it in math. So we need to show this in a different way. So I want to show what is the 6th root of 3, but I actually want to show that as an exponential, a fractional exponent. So again, right, if I'm thinking about 3, right, here is 3 to the 0 power, which is 1. Here is 3 to the 1st power. This is the 6th root, right? So I need 6 of these to multiply together to get 3 to the 1st. So I have, let's go, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, right? This is the 6th root of 3. We have 6 of these 6 roots of 3. Notice, there's only one 6th root of 3. So that gets me to right here. So what power is this? What fraction? If this is 0 and this is 1, this is 1/6. So 3, the 6th root of 3 is actually 3 to the 1/6 power. Because it's just one of these. If I had 2 of these, it'd be 3 to the 2/6 power. If I had 3 of these, it'd be 3 to the 1/2 power. 3 out of 6, and so forth. So now, I can say y equals 50 times 3 to the 1/6 power to the x. And I have to use my properties one more time now. Because I don't really want this inside of here. This doesn't make a lot of sense. I don't want this inside of here. So what I'm going to do, what if I said I had x squared to the third, that equals x to the 2 times 3, right? Which is really x to the 6th. I'm going to use the same idea here. I'm going to take 3 to the 1/6 times x, which is 3 to the x over 6. So now, my final answer is going to be y equals 50 times, so I need to move that down, I don't have enough space. Which is y equals 50 times 3 to the x over 6. Then you might be asking yourself, one, can I even see this? Yes, you can, so that's good. You might be asking yourself, well, why do I want to show it this way? Well, the key to showing it this way is this actually tells me what's really happening in this chart. Because if I go back here, and I look at this chart, right? Well, how did I go really from 50 to 150 times 3? It's really tripling. There's the 3. So it's actually showing me, oh, it's really tripling. But the thing is, it's not tripling in one step. It's tripling in 6 steps. And this shows me how many steps it takes for it to triple. Hopefully you're like, I can see why that's important, Bass. Or maybe you're like, I don't know why that's important. But in any case, like I could have said, you know, the 6th root of 3, and I could have put some weird number, 1.00215, or whatever the 6th root of 3 is, but that doesn't really tell me how this thing is ultimately changing. Once I know this, I can look at this and I say, okay, 50 will triple every 6 steps. It will multiply by 3 every 6 steps, and I can see that information from right here. Dude, I'm tired. It's Friday afternoon. It's almost 4 o'clock. I need to get out of here. Snap, I'm supposed to shout out. Man, I got like a list. Okay. I owe this girl a shout out from a while back. Shout outs right now go to Chloe in Tillis's class. Told you I got you. Actually, you know what? I'm going to throw another one in there because I got like a list. I literally have a list in my phone of people I got to shout out to. Chloe, you're crossed off the list. You got the big shout. Shout out to Michelle in Tillis's class as well. The first person came up to me and was like, Bass, why'd I get all 4s on my test though? Shout out to her. So there we go. There it is. Have a good weekend.